So, welcome back again to my channel. By the way, I'm Gutierrez Tunnel Day, and for today's video, I'm going to make a summary video for chapter 6, which is summary 2.6, and it is entitled Network Layer. So, network applications and services on one end device can communicate with applications and services running on another end devices. So the protocols of the OSI model network layer specify addressing and processes that enable transport layer data to be packaged and transported. So the network layer encapsulation enables data to be passed to a destination with a network or another network with minimum overhead. So this chapter focuses on the role of the network layer. So for more summary, let's watch this. So the network layers have addressing and devices, encapsulation, routing, and encapsulation. So we have a four bases of process and network layer. So the first is we have the addressing end devices. This end devices is it must be configured with a unique IP address for identification of the network. So encapsulation, we have the network layer encapsulates the protocol data unit PDU from the transport layer into a packet. So the process of adds IP headers information such as the IP address of the source. So the sending and destination is receiving host. So we have been routing. The network layer provides a services to direct packets to a destination host on another network. So to travel the other networks, the packet must be processed by a router. So the role of the router is to select the best path and direct packets towards destination host in a process known as routing. So in the encapsulation, when the packet arrives at the network layer of the destination host, the host checks the IP header of the packet, and if the destination IP address within the header matches its own IP address, the IP header is removed from the packet. So the next we have a network layer protocols and encapsulating IP. So these are several network layer protocols in existence. So there are only two network layer protocols that are commonly implemented. So it's Internet Protocol version 4 and Internet Protocol version 6. So Internet Protocol version 4 we have a 32 bytes and in 64 bytes, and Internet Protocol 6 version 6 we have a 128 bytes, I think. So encapsulating is encapsulates the transport layer segment or other data by adding an IP header. So this is header used to deliver the packet to the destination host. So the IP header remains the same from the time the packet leaves the source host until it arrives in the destination host. So the characteristics of IP, we have IP has designed a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of networks. So the protocol was not designed to track and manage the flow of packets. These functions, if required, are performed by other protocols and other layers. So characteristics of IP, we have a connectionless, means you don't need have to a connection to the destination to establish before sending the data packets. And also best effort, IP is inherently unreliable because packet delivery is not guaranteed. So media independent, it's independent of the medium. Operation is independent of the medium of copper, fiber, optic, or wireless carrying the data. So IP connectionless. Connectionless data communications work on the same principle. So as I said, if the IP is connectionless, you don't have need a connections to send the IP in to send the established data before sending it. So just sending it without a connectionless, and so it work on the same principle without a connection. So the best effort delivery in IP is unreliable means that IP does not have the capability to manage and recover from undelivered or corrupt packets. So this is because while IP packets are sent with information about the location of delivery, they contain no information that can be processed to inform the sender whether the delivery was successful. So the next is we have a IP media independent. So it is the responsibility of the OSI data link layer to take an IP packet and prepare it for transmission over the communication medium. So this means that the transport of IP packet is not limited to any particular medium. So in IPv4 header, as I said, we have a version we have it contains a 4-bit binary value set to 0100 that identifies this is this is as an IP version for packet. So differentiate services or diff serve or DS. It formally called the type of service or TOS. Field the DS field is an 8-bit field used to determine the priority of each packet. So time to live contains an 8 binary value that is used to limit the lifetime of a packet. So the packet sender sets the initial TTL value and is decreased by 1 each time the packet is processed by a router. So in protocol, field is used to identify the next level protocol. This is 8-bit binary value indicates data payload type that the packet is carrying, which enables the network layer to pass the data to the appropriate upper layer protocol. So source IPv4, like I said before, we have it contains a 32-bit binary value that represents the source only in IPv4 address of the packet. So the source IPv4 is always a Unicast address. So here we have a limitations of IPv4. We have IP address depletion, internet routing table expansion, and lack of end-to-end connectivity. So in IP address depletion, the IP has limited number of unique public IPv4 address available. So in internet routing table, a routing table is used by routers to make best path determinations. So as the number of servers connected to the internet increases, so too does that the number of network routes. So the lack end of end-to-end connectivity is the network address translation or NAT is a technology commonly implemented within the IPv4 network. So NAT provides a way for multiple devices to share a single public IPv4 address. So introducing IPv6. So increase address space, IPv6 address based on 128-bit. So it's more larger than a IPv4 with 32 bits only. So the packet handling is the IPv6 header has been simplified with favor field, so eliminates the need for NAT. So which with such a large number of public IPv4 addresses, NAT between a private IPv4 address and a public is not needed. So next we have a encapsulating IPv6 as you can see here in this image. So IPv6 header, so we have a version, traffic class, flow level, payload length, next header, hop limit, source IPv6 and destination IPv6. So the larger bit here is the source IPv6 address, which is 128-bit. And the next is we have a destination IPv address. This is 128-bit also. And the next one is we have a flow label. This is the 20-bit field. Suggests that all the packets with the same flow label receive the same type of handling by the router. So the next one is we have a payload length. We have a 16-bit field here indicates the length of the data portion or payload of the IPv6 packet. And the next is next header, traffic class, and hop limit. And the last one is the version, which is a 4-bit binary value set of 0110 that identify this is an IP version 6 packet. So host forwarding decision, a host can send a packet to itself. A host can ping itself by sending a packet to a special IPv4 address of 127.01.0.1, so which is the referred to as the loopback interface. So local host, this is a host on the same local network as the sending host. The host share the same network address. So in remote host, this is a host on a remote network. The hosts do not share the same network address. So the next is we have default gateway. routes traffic to the other network as a local IP address. So the default gateway is the network device that can route traffic to other networks. So it is the router that can route traffic out of the local network. So router packet forwarding decision. So we have a from here which is directly connected routes, remote no routes, default routes. So in directly connected routes, these routes come from the active router interfaces. So routers and a directly connected route when an interface is configured with an IP address and is activated. So we have remote routes. These routes come from remote networks connected to the other routes. So default route is like a host router also use a default route as last resort if there is no longer route to the desired network in the routing table. So directly connected routing table, we have C and L. So when a router interface is configured with an IPv4 address, subnet must and is activated. The following two routing table entries are automatically created. So in C identifies a directly connected network and in L identifies that this is local interface. So we have route source, destination network, administrative distance, metric, next hop, route timestamp, and outgoing interface. So we have been next hop address. So it's important to understand that the packets cannot be forwarded by the router without a route for the destination network in the routing table. So a router is a computer. So in different types of business and networks, we have a branch, one service provider. So in branch, teleworkers, small business, and medium-sized branch sites include Cisco integrated services routers. So in one, which is worldwide area network, large business organizations and enterprises. So service provider is a large service providers includes Cisco ASR, Cisco CRS, the 3-carrier routing system and 7600 series routers. So router also requires central plus processing unit or CPU, operating system or OS, memory consisting of random access memory, RAM, read-only memory or ROM, non-volatile random access memory, NVRAM, and flash. So we have a router memory, we have a RAM, ROM, NVRAM, and flash. So here we have a managed ports, in-band router interface, Ethernet LAN interface. So perform post and load bootstrap program. We have a locating and loading Cisco IOS, locating and loading the configuration file. So here in ROM and ROM, so this ROM is sending to a post and this ROM is sending to a bootstrap. So after you send ROM to post is perform post and ROM bootstrap is load bootstrap. So next is we have a basic router configuration step. So the show version command display information about the version of the Cisco IOS software currently running on the router. So the version of the bootstrap program and information about the hardware configuration, including the amount of system memory. So to configure the device name, you need to type host name. So secure the user exec mode, just type line console 0, password login, and secure remote telnet. You have to type line BTY015, password login. So secured privilege exec mode, just type enable secret password. So secure all passwords in the configure file. So service password encryption. Provide legal notification, just type hashtag banner MOTD delimiter message delimiter. So save the configuration, just type copy running dash config start up config. So configure router interface. So we have a two here we have 2 gigabit internet interface and a serial 1 interface card consisting of two interfaces. So in 2 gigabit Ethernet interfaces, we have a gigabit Ethernet 0-0 and serial 1 interface card we have consisting of interfaces serial and SO serial. So use the no shutdown command activates the interface and it's similar to the powering on the interface. The interface must also be connected to another device such as switch or a router for the physical layer to be active. So we have a verify interface configuration here. Just type the show IP interface brief command and it shows the command that you type in your command prompt. So we have a other interface verification commands here, which is IP route, show interface, and show IP interface. So show IP route displays the contents of the IPv4 routing table stored in RAM. So next is display statics for all interface on the device, and the next is displays the IPv4 statics for all interface on a router. So for an end device to communicate over the network, it must be configured with the correct IP address information including the default gateway address. So to configure the default gateway on a switch, use the IP default gateway, and the IP address configure is that of the routing interface of the connected switch. So that's all for this video. I hope you enjoy and learn for this video. So that's all. Thank you.